And it's good if we can just figure out a maximum value for this, because depending on the part of the audio, no, I won't say anything more. We don't have to worry about the sample level. We'll just look at buffer level. So say this is 3 buffers or 10 buffers that slip by. Yeah, and notice that you will not have a case where the sound comes out of the output before. You'll never get this case where the sound comes out before you put it into the memory callback, the callback buffer, because speakers cannot predict the future yet. So we don't have to worry about that case, fortunately. If that kind of thing becomes possible, we'll probably we won't be worrying about these kind of things and just have fun time traveling. So for now, we just worry about the end. So how can we get this latency time? Well, there are going to be several methods. I haven't looked into it yet, but you can query the core audio for a latency, output latency, and we can do some Googling right now for that. The other one is the experimental method, if you don't trust core audio. And sometimes, like on Linux, I use port audio a lot to do just as a layer between my code and the OS audio code usually. And you can set latency and get latency from there. But there are some times where the OS cannot provide you that information. So you could do something experimental, like you output a sound and take input. And in our case, we have both mic and speaker, so that's not an issue. It's an issue if they plug in headphones, though. But you output a sound, and you take the input, and you just assume 0 latency, and you see how much the audio, how late the audio is. And you have to do that several times, because it depends what part of the buffer you put the audio in. I mean, anytime you do that kind of experiment, it's good to do it several times and take an average and add a little bit or something, or the maximum. But, you know, I don't think we have to do that. Let's first try the latency issue. So, let's see, I was studying some Japanese. But latency is iPhone core audio latency. And we're using audio units. Specifically, we're using the remote I/O audio unit. So I bet there's a bunch of stuff already. Let's see what we get. Okay, I wonder if he computes his low latency. Well, if you're saying low latency and you're talking about it, it might be... Oh, this looks pretty cool. This must be a guy that uses Reddit. Or Reddit. I obviously don't use Reddit enough. Actually, I think I've seen this guy's blog before. Patrick O'Keefe. I've been meaning to post this for a while now. Yeah, it's not documented very well. I'm not talking about his stuff, I'm talking about remote audio I/O. Or remote I/O audio unit. Okay, so it's using the small callback buffer. You know, another thing we could do is also we can change our latency. We can say use a smaller buffer, but we're still going to have to deal with this problem. Yeah, 5 millisecond latency is pretty good. That is pretty good. I mean, I think my Army Fireface, it's a pretty good piece of hardware. I think that's like 3 milliseconds, 3.5 milliseconds or so. I wonder if he tested it. Oh, I've seen Mike Tyson. Okay. Oh, and look, here's mine. I didn't finish my post yet. I should do that. I think I'll blog that and make a video about it at the same time. Okay. So I've been learning about the remote audio I/O unit. Yeah. Okay, so let's just try query audio unit latency. Setting arbitrary sample rate base for audio API. How to calculate latency. There we go. When is this message from? 2010. Okay. Minimum latency of an audio stream on an audio device is the sum of presentation latency, okay, audio device property latency, stream presentation latency, device safety offset. Latency between okay, I'm not sure exactly what stream presentation latency and device presentation latency are. And I wonder if I don't know if this corresponds to my problem, or it's for his audio device. I think he was using a different output method. Okay, all I need is latency remote audio unit query. Okay. Let me think about this for 1 second. How about audio unit query latency? This only really makes sense for an I/O thing though. So yeah, we are using audio session. And I bet this is what is talking about us with the 23-second latency. Oops. If the system's audio default latency Okay. That's interesting. I'd be curious about this for recording apps. Lower consumption. Yeah, because that's about screen refresh rate. Okay, so there's not an actual computation for that. But they just said the default is 23 milliseconds. Well, you know what? I don't want to spend too much time looking for that. I'm sure there's a system call to query a few things. But we can always overcompensate. So what we do is, here's the input manager, and the case we are looking at is re-enabling the mic too early. So what we do is, in our input manager update call, this is where we control the mic, and you see we have an empty handler. Let me clean that up. Yeah, then you can see things. Okay, so we can add some extra conditionals here. So we say you can even use the date class, because this isn't a process intensive thing. So we use NSDate. So that means we have to add NSDate to input manager, because this is a state variable. This is a C++ class, no? Yeah. So we can use Linux time. I don't know if that is the best idea on the iPhone. But actually, yeah, it probably works. What was that called? iPhone milliseconds even. Time. Yeah, they're going to use NSDate. I don't think it was that one. No, I was thinking of uSleep, and that's not exactly what we want. Yeah, I can't. It's kind of embarrassing. In this time interval. Mock absolute time, yeah. Alright, let's just use NSDate. Last mic mute time date. Okay, so we will have to do a little bit of setup, but for now let's just assume we did. We initialize the stuff, and every time we get in here, we